In our last video, we explored the heart of particle accelerators, those magnificent machines that propel subatomic particles to near-light speeds. Today, we'll dive deeper, exploring how particle accelerators unlock the universe's greatest mysteries and tackle humanity's most pressing challenges. Get ready to explore the incredible applications of this groundbreaking technology. It's a journey you won't want to miss. Imagine peering into the very essence of the universe, witnessing the fundamental building blocks that make up everything we know. Particle accelerators like the Large Hadron Collider recreate conditions similar to the Big Bang, allowing us to study the most basic constituents of matter. The discovery of the Higgs boson stands as a testament to the power of particle accelerators in unlocking the universe's deepest secrets. The universe, in its infancy, was a hot, dense soup of elementary particles. Particle accelerators act as time machines, recreating these primordial conditions to study the processes that unfolded in the universe's earliest moments. This provides invaluable insights into the formation of the universe and the fundamental forces that shape the cosmos we observe today. From the vastness of the cosmos to the intricacies of the human body, particle accelerators are revolutionizing healthcare. Proton therapy uses protons to target and destroy cancer cells with remarkable accuracy, minimizing damage to surrounding healthy tissue. Particle accelerators are giving hope and healing to countless individuals battling this devastating disease. Our ability to see inside the human body without invasive procedures has revolutionized medicine. Particle accelerators produce short-lived isotopes used in PET scans, creating detailed images of organs and tissues. PET scans are invaluable for diagnosing a wide range of conditions and monitoring disease progression. Imagine being able to manipulate matter at the atomic level, building materials with unprecedented strength and functionality. Particle accelerators bombard materials with beams of ions or electrons, allowing scientists to analyze their atomic structure and study their properties. This knowledge is crucial for developing new materials with enhanced properties, driving innovation in materials science. The digital revolution relies on our ability to etch smaller, faster, and more complex circuits onto silicon wafers. Particle accelerators, particularly ion implanters, are essential tools in semiconductor manufacturing, doping silicon wafers with impurities to alter their electrical properties. As we demand smaller, more powerful devices, particle accelerators will continue to advance the frontiers of microelectronics. Nuclear power generates radioactive waste that poses significant environmental and safety concerns. Particle accelerators offer a potential solution by transmuting radioactive waste into less harmful or shorter-lived isotopes. This technology holds promise for making nuclear power a more sustainable energy source by reducing the long-term risks associated with radioactive waste disposal. The quest for clean, sustainable energy sources is one of the most pressing challenges facing humanity. Particle accelerators offer possibilities for unlocking new frontiers in energy production, particularly in nuclear fusion. Scientists use powerful lasers and particle beams to create the extreme conditions needed to initiate and sustain fusion reactions. Particle accelerators are at the forefront of this exciting endeavor, pushing the boundaries of science and engineering to create a brighter energy future. From unraveling the mysteries of the cosmos to revolutionizing healthcare and transforming industries, particle accelerators stand as testaments to human ingenuity. Did you know that particle accelerators are also used to study ancient artifacts and artworks, helping us authenticate their origins? Join us in our next video as we explore the future of particle accelerators and the exciting possibilities that lie ahead.